In this lesson, we're going to look at the different types of transceivers our data center support. The reason we have these transceivers is because in the past, you would buy a switch with a certain port configuration, and then you were stuck with that particular port configuration. In this case, I can have a port with an open slot that I put a transceiver in. And when I put that transceiver in the port, it changes the type of media that I can support in that port. So for instance, if I needed a fiber connection, I could put a transceiver in that supported a fiber connection. If a year later that fiber connection changed to a copper connection, I could pull that transceiver out, buy a new transceiver, which is much less expensive than buying a new switch, put that new transceiver in, and then plug that cable into that port. So it gives us a lot of flexibility to support the different media types that we talked about in the previous lesson. And in this case, I have many different types of transceivers that will fit in a Cisco switch depending upon the speed of the media, or whether it's fiber, or whether it's copper. And I can see a few here on this slide. For instance, on the left, I have an SFP transceiver, which stands for Small Form Factor Pluggable Transceiver. I have an SFP Plus, which is basically the next version of that actually draws less power than the small form factor pluggable. Below that, I have a QSFP, which is actually geared towards 40 gigabit speeds. So the SFP Plus can actually support 10 gig speeds, where the QSFP can actually support 40 gig speeds. The other example is I may need a SFP that supports copper. So in that case, I would need a GLC-T to support our copper connectivity into that switch. In recent years, we've actually come up with what we call a twin-ax cable, which is on the right. That twin-ax cable is a less expensive copper cable that is capable of doing 10 gig speeds, but has the SFPs actually soldered on the end already. So for instance, if I was going to buy a 10 gig fiber transceiver, I might pay close to $1,000 for that transceiver, or I could buy this copper cable that can cost around $260 that has the transceivers already built in. And if the device is actually close enough to each other, say between 1 and 3 racks away, I can actually just buy this cable, plug each end into the switch, and I'm off to the races. We also have what we call optical cables that are in these pre-made distances as well and can support speeds up to 40 gig. The twin-ax cable and the optical cables actually come in two different configurations that we call active and passive. If it's a passive cable, it actually does not draw any power from the switch. If it's an active cable, it draws power from the switch to make that connection. You definitely want to check whenever you're cabling any type of infrastructure and connecting any types of switches. You want to check to make sure that you have the right transceivers to support the right type of media, and you want to check if you're going to use a twin-ax or a pre-made optical cable, whether or not you need an active or a passive cable, and that can change per switch or even per line card. I've also included a link at the bottom of this page that brings you to the Cisco website where you can view pretty much all the different transceivers that we support. And there's literally pages upon pages of 10 gig transceivers and 40 gig transceivers. So I definitely would encourage you to go out and take a look at that and see some of the most common transceivers out there, for instance for multi-mode fiber, and become familiar with those, because they may ask you what some of the differences are or what speeds or distances a certain transceiver supports on the test. Please join me for the next lesson, 4.7, examining servers and their components.